Today we're working on combining functions and composite functions. Our goal is to find the sums, differences, products, and quotients of two functions, form average cost functions, and find composition of two functions. Here are all of our operations. You can pause right now and take notes on this table so that way you have how will we work out adding functions, subtracting functions, multiplying functions, and dividing them. Okay, let's look at an example. If f of x equals x cubed and g of x equals x minus 1, find the following functions and give their domains. So we'll start with f plus g of x. From our table, we know that is f of x plus g of x. F of x is x cubed, adding g of x plus x. Actually, g of x is x minus 1, so it's going to be x cubed plus x minus 1. And since these have no like terms, that's where we stop. Then we give the domain. So is there any restrictions on what x values that we can plug in here? Specifically, you want to pay attention if you have a radical or a fraction, because we can't put a negative number under a radical, and we can't put a 0 in the denominator of a fraction. This one doesn't have any of those, so our domain is all real numbers. Next we have f minus g of x. So we take f of x, subtract g of x. F of x is x cubed minus, I'm going to put parentheses around it so we don't lose track of our negatives. G of x is x minus 1. This is x cubed minus x plus 1. Domain, no restrictions on x, so all real numbers. Next we have f times g of x. So we have f of x times g of x. That would give us x cubed times x minus 1. On this one, just distribute x cubed times x to the 4th. X cubed times negative 1, negative x cubed. Again, there's no restrictions on what we can plug in here, so domain is all real numbers. Lastly, we have f over g of x. So we have f of x divided by g of x, x cubed divided by x minus 1. This one's as simple as it gets. We can't simplify any more. And so our domain is going to have one restriction on it because x minus 1 is in the denominator. We cannot have x minus 1 equals 0. So that would mean that x is not allowed to be 1. That's our domain. All real numbers except 1. Okay, let's do an application. The demand for a certain electronics component is given by P of x equals 1,000 minus 2x. Producing and selling X number of components involves a monthly fixed cost of $1,999 and a production cost of $4 for each component. Write the equations that model total revenue and total cost as functions of the components produced and sold in a month. Okay, so they've given us the revenue. P of x equals 1,000 minus 2x and times x. We take the demand times however many we're selling. So to write that out, I'm going to put revenue represented by R of X is going to be our P of X times however many we're selling. Writing these out, P of X is 1,000 minus 2X times X, the amount we've produced and sold. Distribute 1,000X minus 2X squared. And that is our revenue, dollars. So this is in dollars. Next, it wants us to find, so we wrote the revenue, we want the total cost. So the monthly total cost is going to be the sum of the variable cost, which was the $4 for every component, $4 times however many we make, and the fixed cost of the 1,999. Adding those together give us our total cost. I'm going to make it C of X. So we take 4X plus 1999. That's our total cost. That's also in dollars. Okay, using this same example, write the equation that models the profit as a function of the components produced and sold during a month. So now we want profit. How do we find profit? Profit is whatever our revenue is, how much we've made, subtracting off how much we've spent, the cost. So I'm going to put our profit as P of X, so capital, is going to be whatever our revenue is, and we're going to subtract off whatever the cost was. The difference between those two things is going to be our profits. We already know our revenue, 1,000x minus 2x squared. Subtracting off, we know the cost, 4x minus 1999. And now we can, first I'm going to rewrite, distributing that negative sign, minus 4x plus 1999, which will leave us with negative 2x squared plus 996x minus 1999. Okay, so now we can find the maximum possible profit. The maximum profit would be x equal negative 996 over 2 times negative 2. Simplifying this would give us 249. And this is finding the maximum. This formula is from a prior lesson, so please review. So now we're going to take this 249 value for our x, find the maximum profit by plugging it into the profit formula, 249. And we plug that in. Which gives us a profit of $122,003. Okay, let's look at another application. Sunny's greenhouse produces roses, and their total cost for the production of X 100 roses is C of X equals 50X plus 500. Form the average cost function. So the average cost function is a quotient. We will take the cost and divide it by our identity, just x. And you can imagine, how do we find the average of anything? We add them all up and divide by how many there are. So we're going to add up all of the cost and divide it by how many there are, x. This gives us the average cost, which we represent with C bar. This gives us 50x plus 500 all over x. Okay, so for which values is the C bar or the average defined? So take a look. We want to know, when is it defined? When is it, are there any restrictions is what it's asking. So we look at it and we say, okay, there's an x in the denominator. That means that we don't want to have 0 things produced. That wouldn't make sense. We'd make no money, right, if we don't make anything. But thinking of it in application, we don't want x to go negative either, because that would mean we're making negative amount of products, and that doesn't make sense in our application. So what we really want to say is x has to be greater than 0. We have to make products to make money, to have an average cost. Okay, let's graph C bar for 0 to 5,000 roses, which would be 50 units. Remember, x is in hundreds. And what can you say about the average cost? So if you graph it, you're putting that into your calculator. Here I have a picture of the graph, and the average cost, we can see that as the number of roses increases, then our cost is going down. So what we would say in general is, okay, the average cost decreases as we produce more roses. Okay, here we have a definition. The composite function, f of g of x, denoted with f a little tiny o and g, f of g, defined by f of g of x. You can see right here that the g of x goes inside, okay? So again, pause here, take some notes, write your definition down, and then restart. Here I've put a function machine, so that way you can have a visual of what's happening when we do a composite function. So I have my input x, and it goes into the function of g, but the function of g is inside of the function of f, so I have to put that into f, and then I get out f of g of x. So you're kind of working from the innermost part outwards. Okay, let's find the composite functions here. The following composite outputs using f of x is 2x minus 5, g of x is 6 minus x squared, and h of x is 1 over x. We want to not only find it, but give the domain. Okay, so we have h of f of x, which is f of x being plugged into h of x. If I do that, that means I'm going to have h of, what is f of x? I'm plugging that in. And then I treat 2x minus 5 as if it were the x value. So now I'm looking at h. It's 1 over x. 1 over x, I'm plugging in the whole thing, 2x minus 5. and that's how we make a composite function. We take one function and we put it inside the other one. Okay, what's the domain? Well, 2x minus 5 is in the denominator, so it's not allowed to be 0. So as long as we find out what that is, that's our restriction. 2x cannot equal 5. Divide by 2. X cannot equal 5 over 2. There you go. So domain is all x except 5 over 2. Okay, same functions, f of g of x. So now we're taking g of x and we're plugging it into f of x. So f of, what's g of x? 6 minus x squared. Okay, then I look at f, and everywhere I have x, I'm plugging the whole g in. So 2, there's an x, 6 minus x squared goes in, minus 5. Okay, I'm going to distribute 12 minus 2x squared minus 5. That gives us negative 2x squared plus 7. No restrictions on this one. Domain is all real numbers. Okay, same ones. Let's do one more. G of f of x. So I'm plugging f into g. So I have g. F is getting plugged in. 2x minus 5. Now I'm looking at g, and everywhere I see an x, I'm putting the whole thing of f. So we have 6 minus 2x minus 5 squared. 6 minus, if I multiply out, 4x squared plus 20x minus 25. So we'll have negative 4x squared plus 20x minus 19. No restrictions. Domain is all reals. Okay, this next part is going to be how you can graph these on your graphing calculator. So if you have two functions, you're just going to use y1 and y2. Then you can enter the sum, difference, product, quotient. You could do the composition in y3. There's all different ways you can use your calculator. Your instructor might go through these in depth. Also, there's a wealth of YouTube videos that you can easily see how to do these things. So I highly recommend at least learning how to use your calculator for these. It's a nice tool. The calculator can do a lot for you if you know how. Okay, if f of x is root x minus 5 and g of x is 2x squared minus 4, graph f plus g of x using the window from negative 1 to 10 and then from 0 to 200. What is the domain? So here we are going to graph it in the graphing calculator, and what I want you to do is set the x from negative 1 to 10 and the y from 0 to 200. Again, if you don't know how to do these things on your calculator, you can easily Google how to graph, use graphing calculator, use TI-89 to find the sum of functions or the difference of functions. These things are all, they've all been done before by somebody and recorded. So here I have some screenshots of what your calculator will look like. For the first function, f of x, I put in y1. For g of x, I put it in y2. And then you can see on y3, all I had to do was put y1 plus y2, okay? That's the one that is highlighted. I have the equal sign highlighted on that one and not any others. That way my graph will only show me what does the sum look like on the graph. Then you make sure that your x values are set and your y values are set, so that way it's not zooming out to some random part of the graph. Okay? Graph f over g of x, find the domain of it. Again, you could do this on your calculator. Same idea. y1 and y2 are in there, and then I just tell y3 to do the quotient of them. Graph it. And then here is a composition, f of g of -3 and g of f of 9. So on these ones, we're still putting f of x and g of x in. Here, we're on the regular calculator page. We're not on the graphing page anymore. But I could still put in, take y1, plug in y2, and in y2, plug in -3. So that way the calculator will automatically calculate for us the composition of this function at that value of -3. Okay, I'm not gonna go over what the homework this was for my section. Double check with your professor, look on Canvas, it's probably posted somewhere, do your homework, ask questions if you need to, go to the tutoring center in the library, free tutoring at ACU, use your resources so that way you understand what you're doing. And of course you can always reach out to me. My name is Sierra Nichols, so that will be my email address, SIERRA. You can type it in and it should pop up for you if you have questions that you need answered immediately. Otherwise, yes, make sure you read your book, do your homework, ask questions, get answers.